Today we are going to look at section 5.2, and our main formulas for this section are going to be the sum and difference formulas, and we're going to look at those for sine and cosine and tangent. Okay. If you're curious about a proof of any of these, there is a link on Canvas to the proof for cosine of alpha plus beta and sine of alpha plus beta. Okay. And now when I say proof of, I mean proof the fact that cosine of alpha plus beta is going to be equal to something that we'll write here in a minute. Okay. But before I write anything here, I want to point out what these things are not equal to. Okay. So I think really one of the most important things to get from these formulas is that cosine of alpha plus beta is not equal to cosine of alpha plus cosine of beta. As much as we'd like to be able to do this, it's just not true. Let's see what is true. Let's see what the identity is, or what these four identities are. So the first one is cosine of alpha plus beta is equal to cosine of alpha, cosine of beta, minus sine of alpha times sine of beta. Cosine of alpha minus beta looks almost the exact same, other than there's going to be a plus sign here. So cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. Now the ones for sine, they actually alternate between sine and cosine, unlike these ones that are cosine, cosine, and then sine, sine. Okay. And let me show you what I mean. So sine of alpha plus beta is equal to sine of alpha cosine of beta plus cosine of alpha sine of beta. And all that's going to happen here with this last formula is it's going to look exactly the same, other than there will be a minus sign here. And again, proofs to two of these can be found already on Canvas if you're curious. Okay. Example 1, find the exact value of each expression. So we're going to see one application to these formulas here at the moment. There are many, but one of these is now we can find the exact value of sine and cosine and tangent of varying angles. Okay? Not necessarily of every angle, but this here, if we can maybe rewrite 15 degrees in terms of some other common angles and apply the trig identities, or one of the trig identities from above, we'll be able to find the exact value here of sine of 15 degrees. So what I'm really looking to do is look for combinations of 30, 45, 60, 90, combinations of these nice angles that we're used to seeing on the unit circle, that either add or subtract to 15 degrees. Okay. There are actually several options that you can choose here, but one of the options that'll give us 15 degrees is 45 minus 30. And if we apply the bottom trig identity here, this would be sine of 45 cosine of 30 minus cosine of 45 sine of 30. Sine of 45 degrees we know to be the square root of 2 over 2. Cosine of 30 degrees, that's going to be the square root of 3 over 2. Minus cosine of 45, which is the square root of 2 over 2. and then sine of 30 is 1/2. The next thing that we're going to do here is do a little bit of simplification. If we say multiply these two terms here on the left, it's going to give us the square root of 6 over 4, and the second pair will give us minus the square root of 2 over 4. And if we take that one step further, we can combine this into a single fraction. And so there is our answer. Part B is going to be a little bit more challenging because we need to come up with two angles in radians that will add or subtract to 5 pi over 12. And let's just start thinking about some of these common angles here real quick. We have pi over 6, pi over 4, pi over 3. We have pi over 2, 2 pi over 3, 5 pi over 6, pi, and I think we have a big enough list here now. But you want to try and add and subtract pairs of these, and hopefully you can find a combination that'll give you 5 pi over 12. All right. One good option is we could take 2 pi over 3 and subtract pi over 4. Let's get rid of our list here. We don't need this anymore. Okay. And let's just verify that this actually works, right? We have 2 pi over 3 minus pi over 4. And if we get a common denominator of, let's say, 12, then we're going to need to multiply this first one here by 6 in the numerator and denominator. So that's going to give us, and how about not 6? How about 4? We'll get 8 pi over 12. And this pi over 4, we'll have to multiply its numerator and denominator by 3. And so that'll give us 3 pi over 12. And so this is equal to 5 pi over 12. So good. We now know that 5 pi over 12 is equivalent to this. Okay. Now this isn't helpful yet because we haven't applied our new trig identity, or one of the new trig identities. And if we move up here a little bit, we can see what this looks like. If you have cosine of a difference, we are using this formula here. It should be cosine of the first angle times cosine of the second angle plus sine of the first angle, and then times sine of the second angle. Okay, pretty straightforward. So this is then cosine of 2 pi over 3, cosine of pi over 4, and then remember it was plus sine of the remaining two, or of the two angles. And so we just need to figure out what all these are equal to. Cosine of 2 pi over 3 is minus 1/2. Cosine of pi over 4 is the square root of 2 over 2. Sine of 2 pi over 3 is the square root of 3 over 2. And sine of pi over 4 is the square root of 2 over 2. And we're almost there. We can, again, do a little bit of multiplication here. We'll get minus the square root of 2 over 4 plus the square root of 6 over 4. And so this is actually looking a lot like the last one. So we have minus the square root of 2 plus the square root of 6 all over 4. All right, let's try out example 2. This one's going to actually require that we use the same identity. Let me remind you of what that identity is. If we have cosine of x minus y, let's do x minus y, then this should be equivalent to cosine of x cosine of y plus sine of x sine of y. And it's just for us, x is going to be equal to 5 pi over 12, and y will equal pi over 12. So what this means then is we can rewrite this all as cosine of x minus y. So that'd be 5 pi over 12 minus pi over 12. Next, let's subtract the 5 pi over 12 and pi over 12. That should give us 4 pi over 12. Which should give us then cosine of pi over 3. And cosine of pi over 3 is equal to 1/2.